Yeah, good morning once again. Uh, I think this video uh is for you to be guided through the logbook so that you use it to complete all your practicals in the logbook. So our first exercise to deal with is verification of Ohm's law. When you look at the papers over there, to tell you that we want to develop the what or verify the relationship between voltage, current, and resistance. We've been doing that in our calculations. But then we are going to look at how this thing can be what can be done practically to establish those kinds of what do we call it? Relationships. So let's see. Within the multisim environment, by now you would have been having some knowledge in how to pick the components, how to connect them, then how to simulate. So we go to our sources. I think for every diagram or every circuit that you build in this particular software, you need a ground. That is the nature of the software. It's not all electronic softwares that behave that way. But for multisim, you should always use a ground. So I take my DC source, that is just a battery to be specific. Then I go for a resistor, which is under basics. So the resistor 2 has been placed. Then I look for an ammeter. An ammeter is under indicators. So I pick the horizontal ammeter because I'm going to place it horizontally. That is simple. So let's see how we can turn the resistor from the horizontal architecture to the vertical. Just Control R to give me this orientation. So I connect everything this way. Then I connect the what? This side too. I think I should be monitoring my time. I have about, is it 30 minutes for me to finish? Is it 30 to 40 minutes for me to finish this video? So let's keep on to the time. So I'm done with the connection, but then the voltage should be 2 volts in the beginning. Then my resistance should stay at 100 ohms. So when we go to, all this is happening at what, page 4. But then let's go to page 5 and see whether there is any directives there. There we have the theory, the procedure to do the work, but actually that's what we are doing. So when we go to page 6, we are having a table there to fill. Under the voltage, you are going to be simulating some values from 2, 4, 6, 8, and 10. But when it comes to our current, the current will be recorded. Then since the resistance is constant, it's 100 throughout. So when I start simulating the circuit, when I have 2 volts, how many amps am I having? I'm having, let's check something here. In electronics, there are some things you shouldn't be, you shouldn't take for granted. You see, we are having 0.02 amps, but then it's not just 0.02, it's negative. It tells you that where the current is coming from is from the battery. The positive terminal of this emitter should have gone there. Then the negative should face the other side. So let's quickly do that. I want to turn it. So I'll take off this line. Then I use Control R to rotate it twice so that now the positive goes to where the battery is connected because that's where the current is coming from. So the positive should go there. So when I simulate it back, I'll get my positive 0.02 as I mentioned. So that is it. Our next point is we are going to see when the thing is increased to 4 amps, 4 volts, what happens? So I go to 4, I go to enter. But remember, we didn't put the circuit off before we did. That's why it is saying the simulation is running. So I just pick OK. I stop it, then I run it again. So there too, we have 0.04. But if you follow it clearly, it is telling that the formula for the current is always the voltage divided by resistance. So every value that you put there if you put, the next one should be 6 volts. If I put 6 volts, it's the same thing. It follows our formula, which is what? I to be equal to V over R. That is it, simple. Now let's go to the next experiment. The next experiment at page 6 is talking of 2 resistors. We have a resistor here. We have this resistor, control copy or control C. Then I do control V. I'll be able to copy and paste. Then I rotate it. I bring it here. The value for the first resistor is 100, but the second resistor is rather 470. I told you that these are the practical resistors that you always see when you get to the lab. So the 2 ohms, 3 ohms, and whatever are not in existence. They come once a while, or we apply them once a while. So when you check the second experiment, that's experiment 1A under page 6. Did I measure the total resistance? Before you measure total resistance, please take off the supply like this. Just remove those lines that connect the supply. Then you bring your ohmmeter here, or you bring your multimeter. So when you look on your right, far right, there are some components listed there. On my far right, the first one is multimeter. We have function generator. We have watts meter. We have oscilloscope in that order. So I'll pick the first one, which is the multimeter. So I connect the positive to this side. You can connect it any way to work, because as for resistance, we don't have restrictions. So you connect this, then you connect this one to this side. Then you start the simulation. When you start the simulation, you will not see anything. But what you should do is that come and double click on the multimeter. You are seeing 0 volts. It's not voltage that we are measuring. But you see the thing is what? Our default is the voltage that is selected. So if you put it at A, you get something else. Then we go to the ohms because we need the resistance. So when I put it on ohms, then I simulate. That is where the total resistance will come. That is 570 ohms. And because they are connected in series, you all bear with me that 100 and 470 we just add because they are in series. As simple as that. So that is that for the exercise at page 6. Now let's go to page 7. Experiment 1B. You measure the total resistance of these 2 resistors, and they are connected in parallel. So let's do that. Let me take off this meter. But let me stop the simulation. Take off the meter. We have another circuit, of which this one is rather in parallel with this resistor. I will check the values too. So we have our connection to be this way. We are seeing head to head, then tail to tail, which tells you that they are now connected in what? Parallel. So how do I measure? I have to first of all take off the supply. Whenever you are going to measure resistance, you take off supply. So I connect this to this side. Then I connect this one to the other side. Then we now simulate. So when we simulate, we have H2.456. So in here, we said you should record the theoretical value, then the simulation value. You see, this simulation value that is H2.456 is what you are recording at the simulation side. But then you have to do some calculations too and get the practical value too and record it there. Because and get the calculated value, which is the theoretical value, that one you record it there. You want to see whether there will be a difference, and definitely there will be a difference. See, if you don't perform the simulation and you put the values there, I will know. So try and do the calculations and put it there. Then you do the simulation too. Fine. Now let's look at the next circuit. The next circuit is series parallel. We have a particular resistor which is in series with the 2 resistors that are in parallel. Let me stop my simulation. So we have another resistor in series with the 2. So let me put the connection that way. But then when we connect this battery, definitely we are going to take it off again when we want to measure the resistance. So let's measure our resistance right away. So let me take the battery off. So at this time, we are talking of series parallel. So let's put the values there, 100, 100, then 4. Is it 470? It's rather 220. As I said, these are our practical resistors. So when we simulate and we double click on this, we have 168.75. So that one too, please go and check the calculations and see whether we are doing the right thing. This and this will be in parallel. After calculating it, you now add to 100 so that you get it as a total resistance. So in page 8 top there, we have the theoretical value whereby you do calculations and record it there. Then you have the simulated value, which is this one that you are simulating. Then you record that one too. Now, we go to calculating for total current in the next circuit, which is at page 8. So it's a simple circuit, which is just two resistors in what? In series. So I think this is just the simple architecture. But we have 100 here and we have 470 here. So let's bring our battery. The battery is 12 volts. So let's quickly do the connection. Let's quickly do the connection. But before we get the current, we have to get our ammeter, and the ammeter should always be connected in series with the circuit. So okay, after the connection, you all know that the positive is in the right hand side and the negative is here. So when we are getting the negative value, you shouldn't be surprised. Okay, so you all know that if I add this to this, I'll get a particular value, which is somewhere 570. But when I divide 12 by 570, I think we'll be getting 0.021 amperes. But then try and do the calculations too and compare. That is at page 8. Okay. There's another exercise at page 9. There we have to measure the total current. I think that one you can do that. You can also do for experiment 1F, that is at page 9. Then we go to page 10. Page 10 is where the problem is because that is the superposition theorem. So let's try that one too together. So that one too, we pick two sources. So we have another battery, which is coming to my right. Then I have two resistors up there. Then I have only one resistor down here. So after doing our connection, we have the complete connection like this. So we are asked to measure the total current through each branch. So let's first of all look at the one coming from this branch. So when I simulate it, but then let's talk of the values in the resistors. This one is 470. This one over here is 220. Then this one over here is 100. But then we have 12 volts and we have a 9 volts battery over here. So after simulating it, we see that the one coming from here is 0.011. Now I want to get the one on my right. I think we can connect an ammeter right away. So let's go in there and get a what? An ammeter. So we go under indicators, pick an ammeter, which is a horizontal one, then we slot it there. But then for the vertical side, I can use a vertical ammeter, then I slot it there. That is simple. So when we simulate, now we see that the value coming from here is 0.0111. The one in this branch is 0.031. Then the one on my right is 0.021. Somebody will ask, the voltage over here is what? Is 9. The voltage over here is 12. But why is it that the current here is not bigger than this? Okay, the fact is that the 12 volts battery here has a lot of work to do because of the 470 ohms that it should overcome. So that is why the current has reduced. But then when you look at the right-hand side, you see that the resistance over there is just 100. So that is why it is a little bit easier for this 9 volts battery to discharge a lot of what? Current into the circuit. So I think I have to pause here, then I do the next video. Thank you.